Hello students, welcome to Distance Learning with Nipendra Acharya. In this video, we are going to learn about a very new topic, and the topic is limit. And this is the first step towards calculus. Calculus is a very vast subject. You will encounter it uh, on future classes, on higher classes in class 11, 12. You will encounter more and more deeply. But here it's just an introduction to limit, just an understanding of the limit on general, in a very simple way, in a very general way. So first, let's understand what actually limit, the word limit means. Before that, let us learn one English word. So we are going to learn an English word, so you may get confused, is this an English class? Hashtag not an English class, it's a mathematics class. No need to get confused. So the word which we are going to learn is approach. So this is a very very common word. We have heard this word many times in our daily life also. So what does it mean? You can check the meaning on dictionary, or you can check on your mobile phone, or you can Google it. So the meaning of word approach is come near or nearer to someone or something in distance sometime. To be near or nearer to some point or some value or something, uh, that means approach. To be near or nearer to some point, someone, there is someone also, something, or we can say in mathematics some value, some point in distance or time. So let's understand the approach more clearly. This is a school bus, you can see, and there is a kilometer stone on the side of the road. 3 kilometer Pokhara. Still there is 3 kilometer remaining to travel by bus. But let me make you one thing clear: the bus is not going uh, to Pokhara. Its destination is not a Pokhara. Uh, the school where the bus will drop the student after one day excursion or one day picnic, or anything, you can say it's returning back from a picnic or excursion or a single day excursion towards its school, towards its destination, which is some meter before Pokhara. Its destination arrives some meter before Pokhara, but right now the bus is approaching towards Pokhara. Although its destination is not Pokhara, but it is approaching towards Pokhara. Still there is 3 kilometer remaining for Pokhara. You can see on the kilometer stone, but its actual destination, but the school, the location of the school is 300 meter before Pokhara. Understand? Before Pokhara, 300 meter before Pokhara. That means bus does not have to go to Pokhara. Now let's see. Pokhara is approaching destination. It's not the actual destination. It's approaching destination. Bus is towards Pokhara. Bus will be near or nearer to Pokhara. So the approaching destination is called, it's the limit. Now limit is so simple, isn't it? Limit is so simple that we can easily understand it. Limit, what is limit? Limit is just approaching destination. In this case, in this practical example of bus, approaching destination is limit. Maybe approaching value is limit. Maybe approaching point is limit, isn't it? We will study that in further slides. So just make your mind clear, make everything clear on your mind, that approaching destination, like approaching destination, approaching value, approaching point is the limit, not the actual destination. Actual destination is not a Pokhara. Its approaching destination is Pokhara. Let me give you one practical example. If you are traveling back to Pokhara from Kathmandu and your house is in Gagangauda, maybe it is in Gagangauda, and when you go to a ticket counter, you have to pay the fare of Pokhara. You have to pay the full bus fare of Pokhara, although you are not traveling to Pokhara, because there is a distance between Gagangauda and Pokhara, isn't it? There is some fare between these two destinations, these two places, Pokhara and Gagangauda. Some distance is there, although the passenger passenger's destination is Gagangauda, he have to uh, pay the full fare uh, of Pokhara. So what we can say is its limit is Pokhara, isn't it? The fare says that limit is Pokhara, although the destination is Gagangauda. So the approaching destination is the limit. In this case, in our case, we will study further more on deeply what actually the limit is. But in the practical sense, you can see the approaching destination is the limit. Now let's move forward. Hope you understood uh, up to here. So make everything clear in your mind that approaching destination, approaching point, or approaching value is the limit, not the actual destination. Limit is not the actual destination. The actual destination is some 300 meter before the approaching destination. Limit on a sequence of a number. Now we are going to study limit on a sequence of a number, and let's create a sequence. How to create a sequence? The steps are given on your screen. You can see the steps on your screen. Let us take a line segment PQ of 8 cm. We have to draw a line segment. You can see on your screen the line segment of 8 centimeter. Now this is a line segment of 8 centimeter. It's PQ. Its name is PQ. You can see the P right there, and Q also. There is a Q here. Now PQ, this PQ line is of 8 centimeter. Now what we have to do is to create a sequence. In the second step, you can see find R. We have to find R as midpoint of PQ. The point R is the midpoint of line segment PQ of 8 centimeter. What does it mean is the value of PQ, the value of PQ, the value of PQ is 8 cm. So the value of PR, the length of PR, actually length of PR will be 4 cm. So you can see the point R here. Now this P to R, the distance between P to R will be, the length of P to R will be 8 cm. Now again we have to find the midpoint S of PR. Okay, now from this PR only we have to find the midpoint S such that PS will be 2 cm. Isn't it? It will be half of PR. Now we can see this is the point PS and its distance, its length is 2 cm. Now again we have to find T, midpoint of PS. Now this is the way, this is the step where we are creating a sequence. PT is equal to 1 cm. Now you can see the point T, now whose length is, whose measurement is 1 cm. Now step 5, similarly we can find the midpoint of PT also. You can see this is the midpoint of PT. Similarly, find the midpoint of U, V and W. You can say U, V and W such that PU is equal to half and PV is equal to 1 by 4, PW is equal to 1 by 8. Now, so you no need to get confused because half of 1 cm is 1 by 2 and half of 1 by 2 is 1 by 4 and half of 1 by 4 is 1 by 8, and if we continue further, then half of 1 by 8 will be 1 by 16 and it will be continued, and some point it will be 1 0 2 4 also. We are making half of everything, isn't it? Now this, if we assume this is U, now midpoint of PU will be V, and again midpoint of will be W, and again we will continue this process many times. Now let's see our sequence is, you can see our sequence. Now our sequence is PQ, PR, PS, PT, PU, PV, PW and so on. Isn't it? It is infinite sequence. We are creating an infinite sequence. Now let's substitute the value of PQ, PR. Let's substitute the value of PQ. The value of PQ is 8 cm. A value of PR is 4 cm. And likewise, a value of PS is 2 cm, PT 1 cm, PU is equal to 1 by 2 cm, 0.5. 1 by 2 means it's 0.5. This value is 0.5. You can use your calculator, and this is 0.25, 0.125. It's decreasing, 1, 2, 5. And if we go further, 1 by 16, value of 1 by 16, if we find the value of 1 by 16, then it will be, I think, 0 point, let's see, 0.0625, 0.0625, and we can find the value of 1 by 32 also. It will be less than 0.0625, and so on. Now let's see 6, what the 6 says. If we continue this process, of finding the midpoints, and this process many times, continue this process of finding the midpoint many times, then at some point the distance between point P and the distance between, you can read carefully this line, distance between point P and that middle point, the distance between point P and that middle point approaches to some value, isn't it? Approaches to some value. The distance between point P, this point P and the middle point. Now it's decreasing. Right here you can see we started with 4 cm. The distance between point P and midpoint R, we started with 4 cm, and it's decreasing. It's decreasing. When it reaches T, it was 1 cm, isn't it? When it reaches T, it was 1 cm. Now when it reaches PW, it was 1 by 8 cm. That means 0.125. Now it's decreasing. Now at some point the distance between the point P and the middle point approaches to some value. If you can easily guess that value will be 0, isn't it? There, the distance between point P and the midpoint approaches. It's not, we can't say it that will be 0. It approaches to 0. At some point it approaches to 0, and the value is approaching towards 0, isn't it? The distance between point P and the middle point is approaching towards 0. Now we can see 0 is limit of our sequence. And why 0 is limit of our sequence? Because the sequence is approaching towards 0. It's decreasing, isn't it? It's decreasing. It was 8 cm, then 4 cm, 2 cm, 1 half, 1 by 4, 1 by 8. In such a way it's decreasing, and it is approaching towards 0. None of the term on the sequence will be 0. Yes, none of the term. This is very important thing. None of the term on the sequence will be 0, but it will be nearly 0. If it becomes 0, then that middle point does not exist. If the distance between midpoint and P will be 0, then that midpoint will coincides with point P. It will be parallel to the P. You can say it coincides with point P. So that is not our sequence, isn't it? Our sequence must have some value, and limit is not the value on the sequence. None of the term on the sequence will be 0. The terms will approach towards 0, and that approaching value is a limit. Like in the previous slide, in the example of the school bus, we saw the approaching destination is limit. Now here the approaching value will be 0. The approaching the sequence, the value, the terms on the sequence will approach towards 0. Now let's see. Let's make everything clear. Now on any sequence, the last term will be very close to a fixed number. will be very close to a fixed number. It will be very close to a fixed number here. In our sequence, it is very close to 0. It will be very close to 0, but not exactly fixed number. Not exactly fixed number. It won't be fixed number. It approaches. It will be very close. It will be very near to the a fixed number. And that fixed number is the limit of a given sequence. So to find the limit of any sequence, what we have to study, we have to notice is where the terms are approaching, where the terms towards which fixed number, the terms towards which fixed number the terms are approaching, and that fixed number will be the limit. So it is very simple. Hope you understood. Let's move now. Example, first example for very short question. What will be the eighth term of sequence? What will be the eighth term of the sequence? Now there is a sequence, there is a decreasing sequence, and it is an infinite sequence also. Now you can see here how the sequence is created, how the sequence is progressing. You can see. Now let's see the solution. You can assume the answer yourself also. Given sequence is, you can see the given sequence 0.9, 0.09, 0.009, 0.0009, isn't it? Now if we just ignore the decimal for instance, then there is 10 in front of 9, there are 20 in front of 9, there are 30 in front of 9, there are 40 in front of 9. This is fourth term, this is third term. In third term there are 30 in front of 9, there are 20 in front of 9, there is 10 in front of 9. So in first term there is 10 in front of 9, in second term there is 20 in front of 9, in third term there are 30 in front of 9. We are just ignoring decimal for just for a second. Okay, now there are 40 in front of 9. So what will be the number of 0 in front of 9 in 8th term? That will be 80. 1, 2, 3, 4, 5, 6, 7, 8. Then it will be 9. So we can put the decimal right here, isn't it? So this is our 8th term. Therefore 8th term is 0 point, all the 7 zeros after decimal, and 9. Now if you wonder how, then there is term to explain you how it becomes. See, number of zeros in first term it is 1, in second term there are 2 zeros. We are just ignoring decimal right now. In third term 30, on fourth term there are 4 zeros. So in eighth term number of zeros must be 8, and we can put the decimal on appropriate place. Okay, now you can pause the video, you can copy this. Next example 2, important example. We have to find the limit of a given sequence. The sequence is given on your screen. It is 1.9, 1.99, 1.999, 1.99999, and dot dot dot. And B 2.1, 2.01, 2.001, 2.0001. Now the solution is first sequence is, now what will be the limit of this sequence? We have to find the limit. Now what we have to see, what we have to observe is where the number are approaching. This number, where is it approaching? Where the given the sequence on the number are approaching, you can easily see 1.9, 1.99, 1.999, there are 4 nines, there are 3 nines, there are 2 nines, and 1. Means these numbers are getting closer and closer, nearer and nearer. They are approaching to a fixed number. They are approaching towards a fixed number, and that fixed number you can see is none other than 2. That means limit is 2. Now you can see the explanation how we conclude that it's 2. The value is 2. Let's see our number lines 0 and 1, and you can see it's 2. Now midpoint of 1 and 2. Okay. Now midpoint of 1 and 2, that is 1.5, and the 1.9. You can see the value now 1.9 right here. It's here 1.9. 1.9 is near to the 2, isn't it? If we round 1.9, if we round off 1.9, then we round off to the nearest whole number, that is 2, isn't it? So 1.99 is even more closer than 1.9, isn't that? 1.99 is even more closer than 1.9, and 1.999 is even more closer than 1.99, and in that way the value, the sequence is approaching towards 2, so the limit is 2. Okay, hope you understand. B, 2.1, 2.01, 2.001, and 2.0001. Now here also this sequence is approaching towards a fixed number, fixed value, and then that fixed number is none other than 2. So the limit is 2. How? Let's see the explanation. Same number line here, 1, 2, and 3. Now that's 2, that is 3. You can see that is 2.5. Its middle point, that is 2.1. Now we can see 2.1 right here. There are 10 divisions between this. You can see the 10 division between 2 and 3, so it is 2.5 and 2.1. Now 2.001, this value 2.001 is more closer than this 2.1. Now this value 2.001, it will be more close, then this value will more close, then ultimately they are approaching towards number 2, isn't it? So our limit is 2. If we round of 2.1, 2.01, 2.001, 2.0001, then we will round it up to nearest number, that is 2. So our limit is 2. Okay, next example. Now this is a very interesting question, very important question also. So it's a long question. You can see the question. A football is hit hard on the concrete, just like while playing in your game period also, you just think you hit hard the ball, volleyball or football, on the concrete surface or ground, and takes the height of 64 feet. When you hit hard on the concrete, it just jumps and takes the height of 64 feet. 64 feet is way more height. Practically it may not be, but let's see it. Let's assume it is 64 feet on rebound. A rebound, in each rebound it raises to a height 3 by 4th of the original height, means 3 by 4 of 64. It rebounds, isn't it? You drop the ball, you hit hard the ball on concrete, and it just bounces off, and it just lands, and it again bounces, and while it again bounces, it takes the height of 3.3 by 4th of the previous fall means right here it is 64 feet, and it goes on the same way. At what height does the ball approach in fourth rebound? It takes many rebound and finally it settles before. Then what we have to find the height it takes on fourth rebound, and what will be the limit of the height. Now the sequence will be created here in the first rebound, second rebound, third rebound, and is in such a way the sequence will be created, and we can easily find the limit from that sequence, limit of a sequence. Now let's see the solution. First let's illustrate it pictorially. A pictorial illustration. You can see this is the surface, this is the surface, concrete surface. This is concrete surface. Now this is the first. Now when the ball was hit hard on the ground, this is the first height attained by the ball. Here it's a 64 feet, and it's in it's getting down, and it touches the surface, and it takes the rebound again. You can see, and it takes the certain height that will be 3 by 4 of the previous fall, means 64. Then it again touches the ground, and it takes the rebound in such a way. It does in so on such way. Now let's see. Now let's see the rough calculation. You can see the rough calculation. 3 by 4 of 64, 48 means in here this height is 48, and 3 by 4 of 36, this height is 27, and so on. Okay, we haven't drawn a completely 64, 48, and 36, and it will goes on and 27. Okay, now first it was 64, and second it is 48, and third it is first it is 48. Sorry, first it is 48. Now means first it takes the height of 64, then it takes the height of 48, then it takes the height of 36. So understand it clearly. First it takes the height of 64, then it takes the height of 48, then it takes the height of 36 and 27, and so on. Okay, now this is the pictorial illustration. Hope you understood it in a practical way. Now remember those calculations which are in the rough, and let's see the solution part. Let's see the solution part, solving part. Now we need our question. So the question you can see on your screen. Now we make our table, a small table. Now rebound, in first rebound, it attains the height attained by the ball is 64 feet, isn't it? We saw in the figure also, in first rebound means while it was dropped on the concrete, hit hard on the concrete, then it takes the height of 64. Then in the second rebound it takes the height of 48. In third rebound it takes the height of 36, 3 by 4 of the previous fall. And in fourth rebound you can see, you can check the calculation yourself. And fourth rebound it's decreasing. We have to see the trend. It's decreasing, isn't it? It's decreasing, the values are decreasing. In fifth rebound you can see it is 20.25 feet, and it continues, isn't it? It continues. At some point it will reside on a fixed value. That value is the limit. And let's go according to the question. As in first, at what height does the ball approach in fourth rebound? You can clearly see in fourth rebound the ball approaches 27 feet. In the fourth rebound, ball approaches height of 27 feet. From the table we wrote this answer from the table. And for the another B, to find the limit, the sequence of height is 64, 48, 36, 27, 20.25. In such a way it's decreasing, isn't it? Now let's see which is decreasing sequence. It's decreasing. And practically what we know is ball settles on surface, isn't it? Ball settles after many rebounds. The ball settles on the ground. It doesn't bounce continuously, isn't it? It settles. The height is decreasing, and it's finally, due to the gravity, it settles. So it settles on the ground. That means the rebound, the distance of rebound, isn't it? The height attained by the ball will be. You can easily guess that answer with this. Uh, with these words, you can easily find the answer. The ball finally settles on surface. The limit of the height of rebound will be 0 feet, isn't it? The ball settles on the ground means it will be on the ground. There will be no height, isn't it? So the limit of the sequence, the limit of the height of the football rebounds will be 0. Limit of the height will be rebound, isn't it? So at some point the height approaches to 0. It won't be 0. If it will be 0, then there will be no height, isn't it? We are talking about the word height. We have to be careful about the height. It's height means there must be some distance from the ground. The height, the sequence of the height is approaching towards 0. It's approaching to value 0. It won't be 0. If it will be 0, then there will be no height. So now there will be exercise for you. I think there is one more example. Let's now example 4. Example 4, very important example. If t, all examples are very important because they are very selected and very very important example are done for as a walkout example. Find the first 5 terms of the sequence. Now its general term is given. You are very much familiar with this Tn value because we have already studied on sequence and series. And limit is limit on a sequence. We are studying limit on a sequence means that means it is similar to the sequence and series. Here Tn is equal to general term is given as 1 by n plus 1, and we have to find the first 5 terms of the sequence and find the limiting value of the last term. Limiting value of the last term if the value of n is taken sufficiently large. If we take the value of n sufficiently large, then what will be the limit of the last term? What will be the limit of the sequence? The last term, now be careful, last term won't be 0 and it won't be that fixed number, not 0, won't be that fixed number. It will approach, it will be near and nearer to that fixed number. It will approach towards that fixed number. Now that word approach is very important here. Solution, let's see the solution. Here our Tn is equal to 1 by n plus 1. Now we start with n is equal to 1. When n is equal to 1, we have to find first 5 terms of the sequence here, like in sequence and series, exactly like in sequence and series. Now the 1 will replace the n variable will be replaced by 1, so it will be 1 by 2, which is 0.5. okay, it's 0.5. You can write here also. When n is equal to 2, now t2 is equal to, now 2 will replace n. Wherever there is n, it will be replaced by 2. That will be 1 by n. Now this is the replacement for n, is equal to 1 by 3. Its value is 0. This is 0.5 and this is 0.5. Now this is 0.33. 0.333 continuously, or you can, here it's repeated, so we can keep dot here. Now when n is equal to 3, now 3 will replace n. T3 is equal to 1 by, now this is the replacement for n, that's value is 1 by 4, which is 0.25. 0.25. Now again, when n is equal to 4, T4 is equal to 1 by, now this is the replacement for n, which is 1 by 5, and its value will be 0.2. 0.2. Now it's decreasing. Is it when t is equal to, when n is equal to, now 5, T5 equal to, T5 is equal to 1 by 5 plus 1, that is 1 by 6, and its value is 0.166, I think. So if we round it up, then it will be 0.667. Now this is the first 5 terms of our sequence. Now the sequence is, you can see the sequence. We have to find the limiting value of the last term, where it is approaching. The last term, where is the last term approaching? Where is the last term of this sequence approaching? That's the limiting value. 1 by 2, 1 by 3, 1 by 4, 1 by 5, and 1 by 6. Dot dot dot. Okay. 1 by 6, and it's dot dot dot. Now, or if we write in decimal form, it's 0.5, 0.333, and 0.25, 0.16, 0.2, 0.1667, and done. Now you can easily guess, when we take the value of n sufficiently large, when we take the value of n sufficiently large, then what will happen? Let's see. It's 0, it's minus infinity, it's plus infinity and minus infinity. Sufficiently large means when the value of n approaches towards the greatest number, that is plus infinity, it approaches, not plus infinity, we can use that plus infinity. We can be near, we can approach plus infinity when the value of n will be sufficiently large. That means when the value of n is right here, it's increasing, and it is towards plus infinity. Then let's do the rough. Let's take the large value. When n is equal to 50, let's take 50, then t50 will be, you can see t50 will be 50 plus 151, that value will be 0.009. When you take the another larger value of n, then it will be 0.000. See this value, it is approaching towards a fixed number. The last term of the sequence is approaching towards a fixed number. That fixed number is, you can see, when n approaches to infinity, means it's going towards the largest value, that is infinity, towards infinity. Tn, Tn is the last term. You will study this in class 10. Tn is the last term, approaches to 0. So the limiting value of the last term when n is taken sufficiently large, that will be 0. It will limiting value will be 0, the last term won't be 0. So remember one thing, this don't forget this concept. It approaches towards 0, it won't be 0. Okay, the value won't be 0, it approaches towards the last term of the sequence, approaches towards, it will be near and nearer to the 0, and that value is the limit. So hope you understand this one. So let's move to another. There will be question for you, exercise. Try this, you can easily try this question, because we have done 3 examples, I think. So all these questions will be covered on those 3 examples. We have to find the 8th term of the sequence in the first question. Limit, you can easily find the limit of the sequence. A variable is dropped. This question is same as our previous example. A general term, exactly same as previous example. Now there are 7 questions, you can see, and these 2 questions are done by one method, and this question is done by one method, and these 3 questions are done by one method, and all the examples will cover this question. 1 2 3 4 questions, 4 different types of questions are there on your screen. So pause this video, try these questions, and we are moving towards a very interesting topic, a limit on a figure, I think. Let's see. Limit on sequence of figures. Now this will be very interesting to learn also. Let's see first. Now this is a circle, you can see it's a circle. Now let's draw a polynomial, polygon of side 3. This is a triangle, also a polygon having side 3. Now let's draw again inside the same circle, this circle. Let's draw another polygon of having side 4. Now this is the circle where now we will increase the number of sides on a polygon. We are going to increase the number of sides on a polygon. Now from 3 we move to 4. Now this polygon has side 4. Let's see another polygon. Now we are going to increase the number of, this we can say it's a rectangle or it's a parallelogram, it's a quadrilateral, isn't it? Number 4 and number 5, that's the pentagon. N is equal to 5. It's a pentagon. Now we are increasing the number of polygon inscribed inside the circle, and we can see in the first figure the black part, the area occupied by the black part is equal to the area of the circle, but here the black part are decreasing. Even more it is decreasing when n is equal to 4, and even more it is decreasing when n is equal to 5. We have to observe this black part outside the polygon. Okay, inside the circle and outside the polygon there is the black part, black area, black region, and it's decreasing. There is complete black. It's like a now when n is equal to 6, Okay, we skip 6. It's n equal to 7. Now you can see the black part. It's decreasing. It's decreasing even more, isn't it? Now when n is equal to 7, let's see what happened when n is equal to 8. It's decreasing more. Let's see what happened when n is equal to 10 in heptagon, in octagon, in what will happen in decagon. Now see, it's only small portion of the black part is shown. You can see only a small portion of the black part when n is equal to 10. Let's take n equal to 12, dodecagon. N is equal to 12, dodecagon. It's dodecagon. Now what will be our conclusion? What's our conclusion? Let's see. Now if the value of n is taken sufficiently large, then what will happen? Let's see. Sufficiently large means, let's take the value more and more. If we continue this process, taking n is equal to 13, n is equal to 14, and let's increase the value of n. Now this figure will be equal to this figure. You just saw the red portion will completely cover the black portion of the circle if we take the value of n sufficiently large. Now this is the limit on sequence of figure. Now you have to draw this on your copy neatly, very precisely. Example 5. You can see the question on your screen. Draw an equilateral triangle. First we have to draw an equilateral triangle, and taking midpoints of each side, draw another triangle. Repeat it several times. We repeat the same process of drawing the triangle from the midpoint several times, and find the limit of length, area, and perimeter of sequence of triangles so formed. Now this is very interesting question. You will love to do this type of question. Now let's see the solution part. First what we have to do is we have to draw an equilateral triangle. Now let's draw equilateral triangle. This is equilateral triangle, and its name is given as A, B, and C. Now we can easily find the midpoint. Now their midpoint are P of side AC, Q of side AB, and R of side BC. Now these are the midpoint, and we're going to draw a triangle by joining these midpoints. Now you can see this, there is a triangle from the midpoint. We have drawn the triangle from the midpoints, and again now there is a midpoint of side PQ also, QR also, and RP also. Let's see. Now X is the midpoint of side QR, Y is the midpoint of side PR, Z is the midpoint of side PQ. Now we can draw a triangle. Now this will also be an equilateral triangle. Each and every time you draw a triangle from the midpoint, the resulting triangle will also be equilateral triangle. So again we can draw a midpoint. We can continue this process many times. The D is the midpoint of YZ, E is the midpoint of XZ, F is the midpoint of YX. Now we can again draw a triangle. We can continue this process many times. Now let's see here. Here, triangle ABC, PQR, XYZ, DEF is a sequence of figure. This is the sequence of figure, and we have to find this limit on the sequence of figure. Now the solution. Now let's move towards the solution part. This entire solution will be on table form. Now you can pause the video, you can draw, and we can quickly move to calculate limit of length, area, and perimeter on sequence of triangle. we can easily calculate. Now first we have to remember what is the area of equilateral triangle, what is the formula to calculate the area of equilateral triangle, and perimeter, isn't it? What is the formula to calculate, to find the perimeter of equilateral triangle? Just recall it. You have studied in class 8. Let the each side of triangle ABC, the original triangle, the bigger triangle, the first triangle in our sequence ABC, let us assume its length be XC. Now in exam there may be a value, okay, there may be given 18 centimeter, 27 centimeter. Right now we are doing by a variable, we are using a variable to find, we can easily find the limit by using variable also. Now axiom, now we need to know, we need to remember, we need to recall this area of equilateral triangle. Now area of equilateral triangle is equal to root 3a square by 4. Now where a is measure of each side. Now again we need the formula to find the perimeter of equilateral triangle also. Now let's recall it. We know perimeter of equilateral triangle is equal to is equal to 3a, where a is measure of side. Now formula perimeter is p is equal to 3a, and formula to find the area of equilateral triangle is root 3a square by 4. Now we are going to use this calculation table. We are going to draw a calculation table where there will be four columns. There will be four columns. The first column there is figure. In second column length, because we have to find the limit of length also. We have to find the limit of area also. We have to find the limit of perimeter also. So figure, the name of the figure, just like triangle ABC, and triangle, another triangle which was inside the triangle ABC, which was drawn inside the triangle ABC by taking the midpoint. Now the length A, for the first triangle ABC, the length will be x. Now area will be root 3, then we can easily find that, and perimeter will be 3x. Now let's see. Now first triangle is ABC, its length x is equal to its length x, its length A is x. Now x is 1x, we can write it as 1x. Now area will be root 3 x square by 4. Now value of root 3 by 4, you can use your calculator. Value of root 3 by 4 will be 0.4333 x square. Now perimeter will be p is equal to 3x. Now it's the first now it is for the first figure. For the first figure, the length is axiom, and area will be 0.433x square, and perimeter will be 3x. Now for the second figure, PQR, it is drawn inside the triangle ABC. You can see, you can go back to this figure, and you can see now the length will be half, because it is drawn from the midpoint. It is drawn from the midpoint, so the length will be half. Now how it will be half? Let's see it. Let's do it roughly. Let's do it roughly. Let's draw a triangle. Now this is axiom. All the three sides are axiom. Now we have drawn a triangle from by taking the midpoint. Now this is axiom, isn't it? Now there is a theorem in class 9 in geometry, compulsory math geometry, that any line passing through the midpoint of two sides of a triangle is parallel to the third side and half of the third side. Means this value will be x. Now same goes with this value and this value. You will understand that while you study that theorem in compulsory math. Now, so by this theorem, we can easily conclude that this value will be x. Any line passing through the midpoint of two sides of a triangle will be parallel to the third side. This is the third side. This will be parallel to the third side and half of the third side. The third side is x. So this value will be x by 2. Okay, sorry, I have written x. It must be x by 2. All will be x by 2. Okay. Now it goes in the same way. It goes for the another triangle which is drawn from the midpoint also. It will be half of x by 2 and half of again x by 4, and on same way. Now if this is half, you understand why it is half. Now then we apply the value of a will be, our value of a will be x by 2, and on all this calculation root 3 by 16 will be 0.108 x square. Now you have to observe this decreasing pattern of the area, decreasing pattern of the sequence, and decreasing pattern of the length. It's decreasing. So for another triangle, it will be x by 2. Now half of x by 2 is x by 4, isn't it? Half of x is x by 2. Half of x by 2 will be x by 4. And in same way, now we have to apply the value of a will be x by 4. In this, every time we have to use this formula, root 3a square by 4. A value of a is x by 4, or you can write 0.25x. Now that will be root 3 x square by 64, and it will be 0.027 x square. Now perimeter also, the value of a is x by 4, that will be 0.75 x. Now again, and for the another figure, DEF, half of x by 4, that is x by 8, that will be 0.125 x. Now A4, the fourth area of the fourth figure, will be way less than the previous one, 0.0067 x square. Now we have to replace the a, the value of a. You have to, every time we have to use this formula. The value of a will be x by 8, or you can use 0.125 x. Now the entire calculation will be 0.0067 x square. Now the perimeter also 3a, formula is 3a, so it will be 0.375 x. Now you can do it. Now if we continue to draw the figure by taking the midpoint of each triangle, then ultimately, finally, from calculation table we can conclude that if we draw sufficiently many triangles by taking midpoints, then finally we will reach at a point that our last triangle, a length of our last triangle will approach towards a fixed value, isn't it? Now that will be limit of length is equal to 0. Limit is 0, not the value of last triangle won't be 0. Okay, if it is 0, the length will be 0, then the triangle won't be constructed. So we can't say the value of the length of last triangle won't be 0. It will be nearly 0. There will be some small tiny looking triangle. Okay, tiny, very tiny triangle can be drawn, because the length won't be 0. The value of length will approach towards 0. Its limit is 0. Now in the same way, if the length will approach towards 0, then the area will also approach towards 0. So the limit of length is 0, limit of area is 0. In the same way, limit of perimeter will also be 0. If the length will approach towards 0, then perimeter will also approach towards 0. If length approach towards 0, then area will also approach towards 0. Now all these are interlinked. Okay. Now there are exercise. One question, only one question. In this question, you can see the value. Instead of x, you have to use 64 centimeter, and same way you have to draw sufficiently many triangles, and you have to find the length of third triangle, area of fourth triangle, which you will find, definitely you will find from table. You can write the answer from the table, and finally you have to find the limit of length, area, and perimeter of the sequence of triangles so formed. Now again, there will be there we will study a very interesting topic, limit on sequence of figures, on the same topic, different part on the same formula. We are going to find a formula to find the length of inscribed square drawn by joining the midpoint of sides successively. Now, in case of triangle, there we no need of a formula. We didn't derive the formula in case of triangle because we applied the theorem. But in case of a square, we need to find a formula because the length of first square is known because it will be given, or it will be x, whatever it will be given. Now, but if we draw another square by taking the midpoint, another square will be formed, but we don't know the length of this square. This is totally unknown. So for that we have to find a formula. So that we can easily find the length of this square. Length of this square. This is square inscribed inside the square. Okay. Now we are going to derive it. It is not necessary for the examination point of view. You only need the formula, but you have to understand how the formula is constructed. Now this is a square A, B, C, D, and D. Now ABCD is a square with length A unit. Suppose this length of this square is A unit. And PQR are the midpoint of side AB, BC, CD, DA respectively. You can see on the figure also. That's the midpoint of A. P is the midpoint of AB, and Q B midpoint of BC, and R midpoint of CD, and S midpoint of DA. AB is equal to BC is equal to CD equal to A because it's C square, so all sides are equal. AP is equal to, now AP is equal to PB, isn't it? That P is the midpoint, so the value of AP will be A by 2 as P is the midpoint of AB. Now value of P will be A by 2, half of A, because P is the midpoint of AB. And AS is equal to ST. S is also the midpoint of AD, isn't it? AS is also the midpoint of AD, so the value of AS will be equal to ST will be equal to A by 2. It will be half of A, isn't it? AS is the half of A. It is the midpoint of AD, so the measure of AS will be half of AD. That will be A by S, as S is the midpoint of DA. Now this is the square, another square drawn by taking the midpoint PQRS. The red color is a square. Now you can see right here, right angle triangle is formed at A. Right angle triangle is formed at A, and we have to find the value. We have to find the measure of PS, PQ, all the measure of this, isn't it? We need a formula. Now let's see. PQRS is a square drawn by joining midpoints PQRS what will be the length of side PQ. Now this is a $1 million question, isn't it? What will be the length of side PQ? For that we are going to derive a formula. All this whatever we are doing is to derive a formula to find the length not only of PQ, another square drawn inside this square PQRS, and another square. Whatever be the number of square, we can easily find its length, measure of length with this formula. Now you can see with this grid, APB is a right angle triangle at P. This color, consider a right angle triangle APS, isn't it? Now you can see, you can just observe this green part. Now where A is equal to AP. Now this is A for AP, okay. Pythagoras theorem ABC. Okay, it's not A measure of side AB. Measure AB is also A, so don't get confused. This A is for the triangle Pythagoras, the right angle triangle ABC, where A square plus B square equal to C square. We are going to apply that formula. So for that A is AP and A by 2, that is B is equal to AS. AS is base, or AP you can say perpendicular, its base is equal to also AC, and we have to find hypotenuse. C is equal to PS is equal to 1. Now these ABC are of Pythagoras theorem. Okay, for a right angle triangle, to apply Pythagoras theorem, we know we know Pythagoras theorem, that is a square plus b square is equal to c square. We have the value of a, that is a by 2 whole square, and we have the value of b, that is a by 2 whole square, and we don't have the value of c, which we have to find. Or a square by 4 plus a square by 4 again is equal to c square. We can add this a square by, we can take LCM now, partition, and or a square plus a square by 4, our LCM is 4, equal to c square. Now or 2a square by 4, we can cancel 2 and 4, we can easily cancel 2 and 4, and its value will be, now here it will be 2, or a square by 2 is equal to c square. Now the value of c will be root under partition, and the value of c will be a square by 2 equal to 0. Now a is in square form, so we can bring a out of the root. A by root 2 is equal to c. Now this is the formula. By applying this formula, we can easily find the length of this square drawn by taking the midpoint of bigger square. Okay, now PQ is equal to QR, which is, they are square, so all sides are equal, is equal to C is equal to root A by root under 2. Now don't forget this formula. C is equal to A. A will be the length of the previous square. A is the length of previous square. Previous, the bigger square. Okay, understand? Don't forget this formula. C is equal to A by root 3 by 2, and we are going to do one very interesting question. You will enjoy doing that question also. So let's move. This sequence, this limit topic is very interesting. Now you can see the question. Each side of a square is 64 cm. Now the value of A is 64 cm. The value of A is 64 cm, and another square we have to draw, and to find the side of that square, we have to use that formula, A by root under 2. If we use this formula, we can easily find the side of the next square which is drawn inside this square. We can easily find the length of the sides of this square. We can easily find the length of this side. This side. Now, the length of the fourth square we can find, length of the fifth square also we can find, length of the third is the perimeter of the third, area of the fifth, and perimeter, and finally we have to find the limit. We can easily do this because we have already done one question. Now tentative figure means a rough figure, sort of not a perfect figure. We have drawn this tentatively. Now this is a square ABCD, BCD, where AB, BC, and CD and DA on the measure is 64. You can see there, that's the 64, and you can see 64 everywhere. It is a square, all sides are equal. Now you can see another square inside ABCD by taking the midpoint P, Q, R, and S. These are the midpoint of the side. P is the midpoint of side AB, Q is the midpoint of side BC, R is the midpoint of side CD, and S is the midpoint of side D or AD. And the red color is a square. Now we have to find the length of this side PS. We can easily find by using this formula, A by root 2. We will do that in the previous in the next slide. And now let's draw another square, which is E. E is the midpoint of PS, F is the midpoint of PQ, G is the midpoint of QR, and H is the midpoint of RS. Now there is another square. We can draw another square. See the pattern. It looks really nice and beautiful. I is the midpoint of EF, J is the midpoint of FG, K is the midpoint of GH, and L is the midpoint of H. Another square is also drawn. You can see M is the midpoint of Li, N is the midpoint of Ij, O is the midpoint of Jk. P is repeated, and we don't have to worry. Okay, it can be repeated, and P is the midpoint of Lk. We can again draw one more figure by taking the midpoint from the square MNOP. You can see T is the midpoint of Mn, U is the midpoint of NO, V is the midpoint of OP, and W is the midpoint of MP. Okay, we can draw this figure many times, many more times. And now let's see summary of this square. The names. Now first square we have drawn is ABCD, second is PQRS, third is EFGH, fourth is IJKL, fifth is MNOP, and sixth is TUVW. These we have drawn six figure because up to 5 the question is asked up to 5, isn't it? Fifth square we have to do the calculation up to 50. It's necessary, but we have 6 squares. Let's see the the calculation table. We need the formula to find the area of a square. We need the formula to find the perimeter of the square also, and we know that formula to find a length of the square. There is formula. There will is formula to find the length of the square. We know a by root 2. A by root 2 is our formula to find the length of the square, which is inscribed inside the original square. A calculation table. Now summary of a square, which we have already seen in the previous slide, that is necessary. So it is a small recap. And we need formula to calculate area of a square. Is a square, where a is measure of side. We need area to calculate perimeter of a square, and also we need formula to calculate length of squares which are inside the square. The squares inside the square, to find the length of the square inside the square, which is drawn by joining the midpoint of previous square, is equal to a by root 2. You know this. Now let's see the calculation table. Now we need 4 columns. In first column there will be name of the square. You can see here, right here, A B C D P Q R S E F G H, and in next column there will be length of a square. For first square it is 64, and for next square we have to calculate from next square. First square ABCD, for the first square ABCD the length is 64. We have missed the question. Is 64, and for the next PQRS and of all other square we have to calculate by using the formula a by root 2. And you can see area A and perimeter P. Area will use the formula a square, and perimeter will use the area formula 4a. Now area ABCD, square ABCD, its length is 64. That means value of a is 64. Its area will be a square. That means a 64 square, that is 4096. Now perimeter will be 4 into 64. That is 256. Now for first square there is no problem. For the next square PQRS length we have to calculate. The length will be 64 by root 2. Now the formula is a by root 2, isn't it? The value of a will be 64. This a will be the length of previous square. Always previous square. Now our previous square is ABCD and its length is 64. Always we have to use the length of previous square, and our previous square is ABCD and its length is 64. Now we have calculated this 32. Now let's write in the decimal form 45.254. It will give us the clear indication that it's the value is decreasing, isn't it? First it is 64, now it is 45. Now let's see the area. Area will be the a square. Now a will be 45.254. Now that's square will be 2048. Now it is decreasing, isn't it? It is decreased, I think, by, it's totally decreased by half. Now on the 64, now the perimeter will be 181.01. Now perimeter is also decreasing, everything is decreasing. Now let's see the next square, EFGH. Now we have to calculate the length of this next square, that is 32 root 2 by root 2. Now a, as I have already said, a will be the length of previous square, that is 32 root 2. Now it's exactly 32. Now we can calculate the area of 32. Area of the square EFGH, the 32 square will be 1024. Now in the same way, perimeter will be 4 into, now why this is in the red color? Because we have missed the question. In question it is asked that we have to find the perimeter of fourth, a perimeter of third figure. Now in question it is asked that we have to find the perimeter of third. So the perimeter of the third is perimeter of the third figure is 120 cm. So it is in red color. The answer is in red color. Now IJKL, we have another square IJKL. We have to calculate the length. Here it will be 32 divided by 32 root 2, which is equal to 16 root 2, which is equal to 22.67. We can observe the pattern here. The length is decreasing: 64, 45, 32 and 22. Now this is in red color because in question it is asked to find the length of fourth square. The length of fourth square is 16 root 2 cm, that is 22.67. Now we have to find the area. 16 root 2 now will be equal to 512. And now the perimeter will be 4 into 16 root 2, that is 90.50. Everything is decreasing. Area is decreasing, perimeter is decreasing, and length is decreasing. And now again, M and OP. I think it's second last figure, M and OP. Now that is 16 root 2 by root 2. Always remember, length will be taken from the previous square. The previous square is IJKL, so its length is 16 root 2. That is 16. Root 2 and root 2 is cancelled. 16 cm. Now 16 is square. It is in red color because in question it is asked to find the area of fifth figure. Now area of fifth figure is 256 cm square. Now let's find the perimeter of fifth figure. That is 64 cm. Okay. Now we no need to do another one, TUVW. It will be enough because we know the pattern, we know the trend. From the calculation table we can easily, let's complete the table. Now from calculation table we conclude, now if we draw sufficiently more large number of sufficiently many squares, then we will reach at a point where the length of our last square will approach to a fixed value, isn't it? For a fixed value it will approach to a fixed value, length will approach to a fixed value, the area will also approach to a fixed value, and perimeter will also approach to a fixed value. Sufficiently, if we draw sufficiently many square, so that fixed value will be limit of length is equal to 0. Means the length of the last square will not be 0, it will approach towards 0, it will be near and near towards 0. If it is 0, then square won't be formed, isn't it? We need to form a square. As we have already said, last square means there is existence of a square. It may be a tiny square, but it has length, it has area, it has perimeter, so its length approaches to, it will be near and nearer to a fixed value, that is 0. So the limit of length is 0. If limit of length is 0, then we can easily conclude the limit of area is also 0. Limit of area is also 0. And also we can conclude limit of perimeter will also be 0. Now you will get exercise. Limit of perimeter will also be 0. Now there are two questions. Try these. Same way, you can do the same, exactly same. You just repeat the process. You can easily get the answer, desired answer. Now let's move to another topic. Limit on sum of infinite series. Now limit on sum. We have studied on limit on sequence of number. Now it's on sequence of number, but sum of numbers. Now infinite series. Limit on sum of infinite series. Well, let us consider an infinite series. Our infinite series is 1 plus 1 by 2 plus 1 by 4. You can see the series here. Let's find S1, means sum of one term, that is 1, isn't it? A sum of S2, that is sum of two terms, 1 plus 1 by 2, that is 1.5. Sum of three terms, that is, you can see we are taking three terms, 1 plus 1 by 2 plus 1 by 4, the sum will be 1.75. And four terms means we need to include 1 by 8 also. 1 by 2 plus 1 by 4 plus 1 by 8. Now the sum of the four terms, S4 is equal to 1.875, and S5 we can take S5 also. S5 means we are going to take five terms, 1 2 3 4 5 up to 1 by 16. We are going to take 1 by 16. Now the sum will be, sum of all terms will be 1.937, and again S6 will be 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32. Now the value will be 1.96875. Now again S7 is equal to 1 entire up to 1 by 64. We are going to take up to 1 by 64 plus 1 by 16 plus 1 by 32, 1 by 32 plus 1 by 64, which will be equal to 1.9843. Now if we continue this process, then S infinity will be, if n is closer to infinity, S infinity will be, what will be the value of S infinity? Now let's see the sequence. Let's create a sequence from this sum as by taking S1 S2 S3, and the sequence of sum of series is S1 S2 S3 S4, and that is, now let's S1 is 1. Let's put the value as 1.5. Now where is this, the last term of this sequence, approaching to us? Which value, which fixed number is it approaching to us? The nearest whole number, the sequence, you can see on your screen, the nearest whole number. You have, I think you have already guessed the fixed number, that number. Now this sequence, the last term of this sequence will be near the fixed value, will be near and nearer to the fixed value. Sum of sequence of sum of series is approaching to 2. It is approaching to value 2, isn't it? It's, if we take more sum, if we include many more terms, then its value won't be 2, but it will be near and nearer to 2. Okay. So the limit of sum, so limit on sum of a given infinite series, the limit on sum of given infinite series is we can observe the pattern here. It's if we round off this value, then the value will be 2, isn't it? 1.98, it will be more closer to and more closer to if we increase the value of n. If it is increase the, it is the first term, second term, third term, fourth term. If we increase the value of n sufficiently more, then the sum will be near and near and near to 2. It will be close and closer to 2. Understanding, we need to understand one thing. So for the purpose of understanding, let us consider an infinite series, a previous infinite series. You can see the infinite series here. Here t1 first term is 1, we can easily see. Second term is 1 by 2, third term is 1 by 4, and common ratio. Now common ratio, its formula to find the common ratio, you will study this in very deeply on class 10, but right now you just understand that common ratio is equal to t2 by t1, second term by first term is the common ratio. And common ratio, you can see, common ratio is ratio of two consecutive terms. It's the ratio of two consecutive terms, first and second, or second and third or fourth. A ratio of consecutive terms where second terms is taken as numerator. Second term is always taken as numerator. You can see right here, t2 is taken as numerator and t1 is taken as denominator. So you just understand that formula is t2 by t1, and it is a ratio between two consecutive terms where second term, t2, or any, if you are going to take a common ratio from third and fourth term, then fourth term is used as denominator and third term is used as numerator. So just understand this. Now let's find the common ratio of this. 1 by 4, 1 by 2 divided by 1, that is 1 by 2, that is 0. It is less than 1. So if it is less than 1, then what will happen? If it is greater than, then what will happen? We will see it last. Let us consider another infinite series also. You can see the infinite series 2 plus 4 plus 8. Here first term is 2, second term is 4, and third term is 8. Now let's find the common ratio as previous, t2 by t1, which is 4 by 2, which the value is equal to 2, and it's greater than 1. Now what will happen if it is less than 1? What will happen? It is greater than 1. Let's see. If common ratio of any infinite series is less than 1, if it is less than 1, then the limit of the sum of such series will be a fixed real number. If it is less than 1, then it will be a fixed real number, the limit of the sum. As in previous slide, we found the limit of this series, this series to be 2, isn't it? Limit is 2 because the common ratio was less than 1. If it is less than 1, then we can easily find the limit of sum of such series, and it will be fixed real number. Now if the common ratio of any infinite series is greater than 1, then then the limit of sum of such series will not be a fixed real number, will not be a fixed real number. So the sum won't be a fixed real number. Okay, understood this thing. If common ratio is less than 1, then the limit of the sum will be a fixed real number. If common ratio is greater than 1, then we won't be able to find a limit as a fixed real number. Now let's move forward. Example 7. The general term of numerical series, you are very much familiar with Tn is equal to 4 by 3, and it's the general term of a series. We need to construct a series. To construct a series, we have to find just 5 or 6 terms, and we can easily construct a series. Is the limit of sum of infinite series a fixed real number? We have to check it. By the same process, we have to find the common ratio. If it is less than 1, then we can find a fixed real number. And let's see solution. Now we have our general term Tn equal to, here we have our general term Tn is equal to 4 by 3n. Now first term T1 is equal to, it is exactly like in sequencing series, it will be 4 by 3. That will be, now do you know what does this bar means? Here it's bar, it is bar above 3, it means 3 3 3 3 3. There is a repetition of decimal. Now T2 is 4 by 3 square, which is 4 by 9, which is 0.4. There is bar here also. The bar means 4 is repeated. It is non-terminating decimal and 4 is repeated. Now when T3 is equal to 4 by 27, which is 1487, 1481. T4, you can see T4 is equal to 4 by 3 to the power 4, which is 4 by 81, which is 0.93. Now construct an infinite series. We are going to construct infinite series. Now you can easily see the value. Now let's find the common ratio and so on. Now we can continue for many more terms. Okay. Now common ratio is, you know the formula, T2 by T1, which is equal to 4 by 9. T2 is 4 by 9. You can see 4 by 9, and T1 is 4 by 3. 4 and 4 will get cancelled. It will be 1 by 3. 4 and 4 will be cancelled, and 3 and 3, 9. 3 1s are 3, 3 3s are 9 can be cancelled, and it will be 1 by 3, and it is less than 1. 1 by 3 is always less than 1. So what we can conclude is, since common ratio is less than 1, the limit of sum of a series will be a fixed real number. We can find a limit of sum of series as a fixed real number. Now continue. Infinite series is part of the same question. Infinite series is, now you can see the infinite series 4 by 9 plus infinite series plus to infinity. We have to write thing here. Now S1 is, first sum is 4 by 3. That's value is 1 by 3. There is bar because it is non-terminating decimal and 3 is repeated. And 4 by 9, S2 is 4 by 9, that is 1.7. It is non-terminating decimal and 7 is repeated. S4, S3 means we have to add these 3 terms, first, second, third, up to 4 by 27, which is 1.979257. Now let's see, 4 up to 4 terms. 4 by 81, we have to do up to 4 by 81. 1.975. Another T5. It is approaching towards a fixed real number, and you can easily guess that fixed real number easily, very easily. I think you have already guessed it, the answer. You have guessed the answer. Now that is 1.9917 T6. If we continue this process many times, then S infinity will equal to what? Now let's see. The sequence of sum of series is, S1, S2, S3, S4, S5, and dot dot. That is, let's substitute the value 1.333. It's non-terminating 777. You can see 1.9257 from here, and 1.97 53 from here, and 1.9917 from here, and 1.9972 from here, and dot dot dot. It is infinite sequence. Now we have created the sequence from the sum of series. Okay. Now that is the nearest whole number. The sequence of sum of series is approaching the sequence of sum of series. These are the sum of series, and we have created the sequence from the sum of series. The nearest whole number, the sequence of sum of series is approaching to that number is 2, isn't it? So the limit of sum of given infinite series is 2. It is approaching towards 2. If we continue many times also, it won't go beyond 2, also it won't be 2 also. So it won't be 2, it won't go beyond 2, it won't be 2 also, it will approach to 2. It will be near and nearer to 2. So let's move forward. We can try these questions. We can easily do these questions. Now limit of a function. 4 is limit of a function. Let's consider a function fx is equal to 2x minus 1. This is a function. We know that. Where f is a generic name for the function and x is its input variable. And let's choose input value. This is the graph of the function. If we draw a graph of this function, then it will be a straight line. You can see this is straight line. Fx is equal to 2x minus 1. And you can see in x-axis it is input. Input will be on x-axis and output will be on y-axis. That means y is equal to fx. Y is always fx, isn't it? We have studied this in function chapter. Y is equal to fx. Now let's choose input as 3.9 and 3.99. We can choose it as 2.9, 2.99 also, 4.9, 4.99 also. Here let's choose 3.9, 3.99, 3.99. Um, let's go near and nearer to value, to a fixed value. What is that value? You know, isn't it? Now what will be the value of the function if x is equal to 3.9? Now let's see, it will be 2 into 3.9 minus 1, that is 6.8. Now what will be the value of functional value at x is equal to 3.99? That will be 6.98. And what will be the functional value of function fx at x is equal to 3.999? The functional value will be 6.998. Now at x is equal to 3.9999, the functional value will be 6.9998. Now let's see the sequence of inputs. 3.9, 3.99, 3.999, and 3.999, and so on, which approaches to, now the inputs approaches to a fixed real number, that is a fixed number, that is, you know very well, that is 4, isn't it? It approaches to 4. Now sequence of output, let's create a sequence of output. Now you can see here the input approaches to 4, isn't it? When input approaches to 4, now you can see the line 4. If we draw a line from the 4, then it meets the graph at this point. X is equal to 4. This is the line. Now let's see sequence of output. Sequence of output like 6.8, 6.98, 6.998. And dot dot dot. Now it is also approaching towards a fixed real number, and that fixed real number is you know very well, it is approaching towards 7. Now you can see in the graph also 7. You can see it is approaching towards. When the value of function is x, then its value will be 7, isn't it? Now let's see. 4 to the 8, 8 minus 1, it's 7. Therefore, what fx is equal to 7. Therefore, 7 is limit of function. 7 is the limit of function. Output is not exactly 7. It is approaching towards a 7. And input is not exactly 4. It is approaching towards 4. When the input approaches towards 4, then the output approaches towards 7. So the limit of the function is when the 7 is the limit of the function f when x approaches to 4. Its limit is always approaching value, isn't it? We know that limit is always approaching value. But in case of function, and if input approaches to a certain fixed value, then output will also approach towards the certain fixed value. That will be the limit of function. Now, you can pause the video. You can draw this this graph also. You can copy this theory. Now let's define the limit of function. Now if the output of a function f approaches to some value k, if the output approaches to some value k, when its input approaches to some value a, now that's the value, some value a means it may be any value. When input approaches to a certain value, then output would also approach to a certain value, and that value that here in this case k is the limit of the function f, isn't it? When input is approaching towards the a, then output is approaching towards k, then that approaching value, that approaching output will be the limit of the function. Limit of the function is the approaching output when input is approaching towards a certain value. To understand it more, in that x was approaching towards 4, isn't it? Approaching app. Okay, let me write in short form. When x is approaching towards 4, then our y, that was fx, isn't it? And fx was approaching towards 7. Now x approaches to 4, then output approaches to 7. Now this 7 is the limit of the function. The 7 can be called as the limit of the function. Example 8. If fx is equal to 3x plus 1, it is a function, given function, then we have to find the value of function at x is equal to 4.99 and 5.01, to which whole number is round up. We can easily round up. We have learned this round up in the junior classes. Now here fx is equal to 3x plus 1 when x is equal to 4.99. f 4.99 is equal to 3 into 4.99. Now as 4.99 is the input value, it takes the position of input variable. Now that is 15.97, and rounded whole number is 16. Now if we round this off, then we can, its value will be 16. We can easily round it off to the nearest whole number. Now again, when x is equal to 5.01, f, now 5.01 is the input value. It takes the position of input variable. It must be 5.01. 5.01. This value will be 16.09. Now the nearest whole number. nearest rounded whole number is 16. So it is rounded off to nearest whole number, that is 16. Is it in both cases? Here input x is equal to 4.99 and 5.01 approaches to 5. In both input also approaches to 5 and output both input approaches to 5, isn't it? It is near to 5. 4.99 is also near. If we round off 4.99, then that will be 5. If we round off 5.01 also, that will be 5. When input is rounded off to 5, then output are rounded off to 16. That's the conclusion. Okay, when input are rounded off to 5, 4.99, if we round it off, then it will be 5. 5.01, if we round it up, then it will be 5. Then their output also is are rounded, is their output is also rounded up to 16. Okay, now example 9, you can see the question on your figure. We have to check, does f1 represent a real number? We have to check when x is equal to 1, and then we have to find the value of x, find the value of fx at these points, and we have to round up the result from 1 and 2. Here fx is equal to x square minus, that's the given function, x square minus 1 upon x minus 1 is our given function. When x is equal to 1, 1 square minus 1 upon 1 minus 1. Now what will happen here? Or f1 is equal to g1 minus 1 upon 1 minus 1, and which is 0 by 0. Now this 0 by 0 indeterminate form, we need to learn one term, that is indeterminate form, the undefined mathematical expressions in the form. If it is in the 0 by 0 form, if it is in infinity by infinity, infinity and infinity plus minus infinity, or 0 to the power 0, infinity to the power 0, 1 to the power infinity, are called indeterminate form. If we come across, if we observe this sort of mathematical expression 0 by 0 or infinity by infinity, then what we have to say, they are indeterminate form. And these are called indeterminate form. They are undefined mathematical expressions. They don't have a definite value for it. We can't write 0 by 0 equal to 0. That will be a mistake. Okay. Now, so which is indeterminate form. So what we can conclude is, therefore f1 does not represent a real number. So it is not a real number. They are not a real number. These all indeterminate form are not a real number. Understand? Here it must be divide, I think. Okay. Divide or multiply sign. Okay, whatever it is. Okay, we just have to understand that this, if we come across these forms 0 by 0, infinity by infinity, infinity minus infinity, infinity plus infinity, and or 0 to the power 0, or infinity to the power 0, 1 to the power infinity, or any value to the power infinity, they are indeterminate form. They are mathematical expression, but they are not a real number. So f1 does not represent a real number because it's in indeterminate form. So it is not a real numbers. So we can conclude like this. And now, okay, let's see the solution part. We need the question, and we have given function is fx is equal to x square minus 1, x square minus 1, and let's do by drawing a calculation table. This is for first one. And fx and round of value. Okay, now this green is for first, and we will do blue for another table. We will construct another table. Now first, when x is equal to 1.1, let's draw the table first. when x is equal to 1.1. Now we can substitute the value of x as 1.1, and you can use your calculator. You can directly write the value, which is 2.1. Now if we round it off, then it will be only 2. Now again another value 1.01. When x is equal to 1.01, now 1.01 will substitute, and it will take the position of x 1.01, and 1.01 is square minus 1 upon 1.01 minus 1. Now its value will be 2.01, and if we round it off, then it will be 2. Now again 1.001 f 1.001 001, that will be 1.001 square minus 1, and 1.001 minus 1, and that's value will be 2.001, and if we round it off, then it will be 2. Now let's close the table. Now we have done it for first and for second, blue, and red for third. Now let's draw the table. Now x, the value of x, and fx, and a round of value. When the value of x is 0.9, now you can substitute the value of x as 0.9, and you can use your calculator, and you can easily write the value, and its value is 1.9. And now if we round 1.9, then what the number will be 2, and again 0.99 f 0.99 will be 0.99 minus 1, 0.99 minus 1, and now this will be 1.99, and if we round it off, then its value will be 2. Now 0.999 and f 0.999 0.999 is square minus 1, 0.999 minus 1. Now its value will be 1.999, and if we round it off, then its value will be 2. The nearest whole number is 2, so our round of value is 2. Let's close the table, and you can see the answer, the entire. Now there are 4 questions for you. You can see the 4 questions. All questions are same. Each and every question are same. Notation. Notational representation of limit. If you remember what we first learned, we learned our English word and we have used that word repeatedly. Now there is a notational representation for the limit. Now that word is approach, isn't it? Now approach has a symbol, a notational representation in limit. Now let's see. Now if x is equal to 1.9, 1.99, 1.999, here x is approaching to a number, isn't it? You can easily see x is approaching towards a number, and that number is 2. Now it can be written as, in notation form, we can replace that word approach by a symbol. You can see the symbol as x takes to 2. Now this arrow is text. Okay, we can write x takes to or x approaches to 2 by this arrow sign. X is going towards 2. It means x is approaching 2. It means x tends to 2. Now read as, if while we are reading, read as x approaches to 2 or x tends to 2. Now let's consider a function. We have a function fx is equal to x plus 1 and let's input value will be x. Now let's find the value of function. Now you can see 2.9 when x is equal to 1.9, 2.99 when x is equal to 1.99, and 2.999 when x is equal to 1.999, and in the same way you can see here fx is approaching to a number. That number you can easily say that is 3. It can be written in the form fx takes to 3, fx approaches to 3, isn't it? This arrow at sign, it is a notational representation for limit. Now if we combine these two means x takes to 2 and fx takes to 3, then we can write these two notation. We can write if x takes to 2 then fx takes to 3, or in more mathematical way, limit. Now finally we are writing x takes to 2 fx equal to 3. This is the perfect way to represent limit. Okay, now this form, if f takes to 2 then fx takes to 3, can be written as limit x takes to 2 fx, the value of fx will be 3. When x approaches to 2, the value of the function approaches to 3, isn't it? It's value, approaching value, it's not the perfect value, it's a limiting value. So if x takes to a, fx takes to fa, then written as this limit x takes to a, then we can write in the sentence form as when limit x tends to a, fx equals to fa. When limit, in this also, here also, when limit x tends to 2, fx is equal to 3, is equal to 3. We can read like this: when limit x tends to a, when limit of x takes to a, it is approaching towards the, then the functional value will be equal to fa, will be equal to whatever the value of fa will be. Now there will be exercise definitely. Example 10. Write the mathematical sentence x approaches to in a notational form. There will be question and the answer is x takes to 4. We in mathematical form we can write x takes to 4. And in mathematical sentence we can write answer 2. You can see we can write x tends to 2 or x approaches to 2. You can write anything. Okay. Now question number 3. Write the notice limit x takes to 2 fx in mathematical sentence. You can see when limit x tends to 2, now this is tends to 2, fx equals to f2. Now this is the value of a. You have to understand x takes to a. Now it has some value too, isn't it? That will be fx equal to f2. Now write the notation this in mathematical sentence. You can see the answer when limit x tends to 2, fx equals to 9. Now here its value is given, so we can write 9. Here value is not given, so I have to write fx is fx equals to f2. We have to replace the value ourselves. Try these questions. You can represent this in a one more question. Example 11. You can see, find the limit of the function. Find the limit of the function fx is equal to, this is the function given. By completing the table, we have to complete the table. The answer lies exactly here. We have our answer here. Now let's start the solution. Solution here, the given function, you can see given function fx equal, now calculation table. Now the table will be a long big table. You can draw vertically also here. This is our table, and let's, the value of x will be on horizontal 0.9. You can see in the table 0.99, 0.999, and in between there will be x. Now where x is approaching from both sides, it must approach from the both side, from left side also, from right side also. This is the approaching from the left side, and from the right side also 0.1, 0.0001, and 0.1. Now from both way, x is approaching from the both way. Also fx also approach from both way. You can see when fx is equal to the x minus 1, x square minus 1, our function, given function is x minus 1, x square minus 1. We can substitute the value 0.9 is equal to, you can use your calculator, 0.9 minus 1, 0.99 square minus 1. After using our calculator, we find the value as 0.526. Okay, now from, we are approaching from the left right now, 0.99, the value will be, you can see the value, you can see the calculation on your screen, 0.99 square minus 1, the calculation will be 0.5025, and again 0.999. You can see the calculation, it's playing on your screen, 0.999 square minus 1. Now this value will be 0.500. Now from the right side, the first value will be 1.1. We have to use first 1.1 as first. Now why we are using 1.1 as a first? Let me explain you. Now you have seen the number line previously also. It's 0 and it's 1, and 1.1 is this value, isn't it? This is 1.1. Now the 1.01 is more near, isn't it? Another, if we draw another line here, it is 1.1, and 1.001 will be more near. It will be more and more near. It will be more and more nearer. We can see with this gray line, it will be nearer to the to our fixed number, isn't it? So we start from here. We start from the distance value, and we come closer and closer towards our value from the right side, and from left side also. See 1.9. We started from 1.9. You can see the number line. It's 0, and its value is 1, and 1.9. If it lies here, right here, then 1.99 will be more closer, more nearer, isn't it? It's 1.9, isn't it? And again another 1.99 will be even more closer, even more closer. So we start from the distance value and we come closer, and closer. So let's continue. Now the value will be 0.4761, and again we will do this value here, 1.01. It's playing on your screen. The value of x is replaced by 1.01 minus 1 and 1.01 01 square minus 1, and which is equal to 0.4975. And again another f is equal to 1.1001 square minus 1. The value will be 0.499. Now you can see x from both sides is approaching towards a fixed value. From left side also, from right side also, it is approaching towards, from left side also and from right side also, you can see the arrow. It's approaching towards 1, isn't it? From left also, if we round it up, then from both sides we get value, exact value, same value, that is 1. And fx from the left side also, from left side and from right side, it is approaching towards a fixed value, that is, you see, 0.47, 0.49, 0.499. If we come even more closer, then we are closer to a value, that value is 0.5. And from left also, from right also, we are converging towards a single value, that is 0.5. That's all. That's what limit and continuity you are going to study in class 10. We have to do from both sides, from left also, from right also. And here you don't have to select the value will be given to you, and you have just have to find and understand the concept that the value is approaching, we are approaching the value from both sides. It goes like that. Now let's conclude it. Let's write in the mathematical way, that is will be limit x tends to 1. When x tends to 1, when x approaches to 1, then the entire function will approach to 0.5. Now this is our complete solution, and I think we have concluded this 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 chapter, and there will be, now try this. There will be few questions. Now approach this value from both sides. Limit, this is the question, and finally we have completed this entire chapter. You can pause the video, you can repeat the video, you can watch many times. If you find useful to yourself, then so don't forget to share with your friend or like or subscribe. Thank you for being with me.